Good afternoon, everyone, and welcome to the Dairy Summit by Wisenetics. This is an event that was especially designed for dairy nutritionists, where we will be discussing the latest industry updates brought to you directly from the world's top dairy suppliers. Our goal today is to provide you with everything you need to know to stay up to date with the latest research in the field without having to leave your home or your car or whatever you are paying attention to us today. And we believe and hope that this event will help prepare you and the industry for future market challenges. I am Dr. Luis Fijareto. I am an associate professor and extension specialist in dairy nutrition at the University of Wisconsin-Madison. And on behalf of the Wisenetics team, I would like to thank you for joining us today. This will certainly be an afternoon with a lot of knowledge and great experiences, and we are very happy that you join us today. I'm speaking directly from Madison, Wisconsin, but I'm sure that we have people from all over the country joining us. So if you are kind enough to do that, we would love to know where you are from. So if you could please post in the chat, our team would really enjoy seeing where do we have people joining us today. I would also like to thank our sponsors because obviously without those sponsors, this program would not be possible. So thank you all the sponsors that kindly agreed to join us today, AHV, ICC, Pro-Earth Animal Health, and VOLAC. And last but not least, we would like to provide a special thanks to our speakers who will be sharing a lot of their expertise and knowledge through this event. And I'm sure that this will add a lot to everyone that is listening. Feel free to also use the YouTube chat if you need help or have any questions. Everything will be answered at the end of each presentation. So without further ado, let's get started. So first, I'd like to introduce our first guest of the day, Dr. Todd Calloway from the University of Georgia. Dr. Calloway will discuss eubiotics and altering the microbial populations in animal physiology. Dr. Calloway, welcome. Thank you so much for joining us today. It's a pleasure to have you here, and the floor is yours.
Okay, thank you very much, and thanks to Wisenetics for having me, for listening to me. Now, I know there's been a lot of talk in the recent years about probiotics, direct fed microbials, and all these issues. And the language has been so confusing to everybody about what are we looking at? Is this a probiotic? Is it a prebiotic? And we kind of want to talk about how we're starting to think about categorizing these and what they look like they're doing. So overall, there's a collective term now of eubiotics, meaning something that does good for a biotic system. So that's the ways that we think of altering the microbial populations. That's always been the story that we've told ourselves, that probiotic approaches or traditional probiotics or direct fed microbials would impact the microbial population primarily. But you'll see from one of the studies that I show a little bit of from around the world, that also impacts directly on animal physiology and animal host gene expression. So it kind of has changed how I think about our probiotic approaches and what we can actually do with them. So sorry about any noise on that one. So for the beginning of our understanding of how microbes interact with the host animal is the original study has now been almost 20 years where they demonstrated that if you had really mice that were grown up germ free with no microbial population in their gut, they would stay thin, whereas conventional mice would get very fat, even eating 1/3 less calories. So that it really was dependent, the physiologic status of these animals, so these mice, on their having a microbial population. Now, when they did a microbial transplant from the fat mice into the thin mice and then put those mice on a diet where they had 30% of the 30% fewer calories, those mice became fat very rapidly. Now, for you and I, where we've been looking at ruminant nutrition forever, where we understand that feedstuffs are fermented by the microbes, produce volatile fatty acids and microbial crude protein that the animal can utilize. Researchers in this area just had not thought of that. So to them, this was really novel information. But to you as a dairy nutritionist, you look at this and say, well, duh, that's obvious. And there were studies that went on back and forth looking at the composition of that microbial population. And this is something you'll see in a lot of papers now, looking at the Firmicutes to Bacteroidetes ratio. And that's a neat concept, but it doesn't tell you the whole story. It's a really crude analysis. So the way I think about how crude that is you're looking at the amount of chordates. If you went out and sampled a 100-acre farm, you count the number of chordate animals, so everything with a backbone, and compare it to the nematodes. That's the level of comparison that we're looking at here. But even with that crude analysis, what we found, or what they found, was there was a microbial population very closely associated with having more fat, being a more obese animal. Now, for people like me, that's a problem. But if we're trying to feed our cattle most efficiently, we want them to be like this because we can feed them less to get the milk production, or if we're looking at beef cattle, to get that physiologic response. Because what's happening is these mice are harvesting more of that dietary energy in a form that is absorbable. So that microbial balance, as you can see, really matters, because if you go too far one way or the other, if you run too much starch in the ration, or you have salmonella, or you don't get enough branch chain amino acids where the branch chain fatty acids will be produced, then the population will get out of balance and you'll have a crash. Your cows will go off feed, you run into major problems all across the board. You run into milk fever, you name it, you start having all these terrible problems. So how do we keep that microbial balance somewhat, at least, in check? Because we used to think about this microbial population just being, they are who they are. There's nothing to worry about. But now we know they do vary a fair amount. And where that impacts us as dairy producers, is most clearly illustrated in this paper on the right by Shabbat. And this was a great study using some dairy cattle. And they had very highly efficient dairy cattle and very low efficient dairy cattle. And they looked at the microbial populations. Now, the way we've traditionally thought of this, and this is very much the dogma, was that increase in microbial diversity was automatically going to be a good thing. And instead, what this study found was the animals with lower microbial diversity were associated with the more efficient animals. The higher microbial diversity was associated with least efficient animals. So that goes completely opposite of what we would have always thought. So when they looked at what the end products of that fermentation were, the answer became really clear that less diverse microbial population was more focused on producing end products that the animal could use rather than producing something else that the animal won't utilize. And the inefficient animals, they had a broader range of end products, but fewer were used by the animal. So even though they were getting the same diet, these animals had a different microbial spectrum, microbial population, and that impacted their growth efficiency, or their milking efficiency, not growth efficiency. And a lot of that was due to certain microbes producing propionate more so than acetate. So it was exciting to see, okay, here's that microbial balance again. How does that affect our dairy cows? So then how do we fix this? How do we take a microbial population and adjust it so that the diversity is such that we are benefiting from that production of the proper kind of end products that are going to help us? So the whole host of products that we've looked at for years, probiotics, postbiotics, prebiotics, all are now kind of lumped together in eubiotics. Now we've looked also at things like organic acids, ionophores have been used a lot, phytochemicals have been used frequently as well as these organic acids. So there have been a lot of approaches, but this eubiotics has kind of been a focus of mine, and really trying to understand how all this fits together for the dairy industry has been one of my challenges for the past few years. So overall, this is the simple kind of breakdown. The old term that people used to have of just kind of generic probiotic approaches, that's largely what we're talking about now is eubiotics. That umbrella of eubiotics covers pretty much everything now, whether you're talking about a live culture or a non-living culture of end products. That's all incorporated, as well as prebiotics, in this eubiotics umbrella. Now you can have a live culture bacteria or fungi or yeast. That's now what we traditionally call a probiotic, meaning it's alive. If it's the non-living culture or end product, that's called a postbiotic. The prebiotics are specifically nutrients that are limiting to that microbial population that's not available to the host animal. That's your oligosaccharides, your MOS, multi-oligosaccharides, FOS, fructooligosaccharides. They're really expensive in their pure form, but they can actually be found in some of the postbiotic products. When we look at them and run them on a GC, we can figure out there that they may be playing a role in that postbiotic action. So these categories, we categorize them, but they're not necessarily exclusive to that. So collectively, these are what we can look at as nutraceuticals. They're nutritive, they can impact food safety, animal health, but there's an implied curative or preventative property that these have. So when we add eubiotics, we can have impacts in the rumen, in the hindgut, or in the host animal. And that's always an interesting concept, thinking about it working on all these different levels. But in the rumen, you're going to get a change in that biofilm. The microbes are going to fight for nutrients against these new players that have come in. You're going to shift that propionate production. You're going to reduce methane production. You're going to have a lot of different effects in the rumen. But they also can have broad impacts in the hindgut, where you're altering that VFA production or increase your competition for those local binding sites, or simply by producing more antimicrobial compounds there in the hindgut. The part that to me has been the most fascinating, the rumen and the hindgut has been kind of old hat. We've known this to a certain degree for a long while. But that host response to probiotic addition or eubiotic addition has been the most exciting development that I've seen in this field in a long time. Understanding that by changing that microbial population, that we're going to change the cytokine responses, we're going to affect inflammation, we're going to have increased antibody responses, And we're going to affect things as simple as the growth hormone production, which is going to impact our milk production. So understanding that particular leg of the eubiotic impacts, to me, is going to be the most exciting thing that we see in the next several years. Understanding how these are actually communicating to the host to make these changes. Again, these are the definitions that we use of the eubiotics, pro and pre and postbiotics. Symbiotics are when we can use either a probiotic and a pre, or a pro and a post, or a pre-post and a pro all together. So it's using them together where they work synergistically. Now, I also include phytochemicals, and you'll hear some more about those shortly from some of the other speakers. But phytochemicals are a really important modifier, and they are considered as or can be considered as a eubiotic, as a way to alter that microbial population and get similar effects. Now, for a lot of people, these probiotic approaches for years were considered, basically this magic foo-foo dust that, we add this and the animal can drive my tractor, will feed each other, they'll have really clean hair, where it really just didn't. It really, you had nothing you could hang your hat on for data. But now, as we've dug deeper into dividing these into their different categories, we can start to make sense of what these products do and what promise they actually hold, and moreover, what we can hold the companies to. So looking at what we think is happening when we're feeding a probiotic or a prebiotic or a postbiotic, any one of those three, or symbiotics clearly, is prebiotics will be feeding a lot of the microbial population, those native members of that resident population. Or probiotics can come in and penetrate that population and become established, or at least penetrate that population. And postbiotics also bring in some of the nutrients to those individual organisms. So that you're taking this resident population and stimulating some members, some of whom are producing antimicrobial peptides, some that are making short-chain fatty acids, but they're using the nutrients for the animal's benefit. But also, there's a lot of pathogens that are encountered by our animals on a farm on a nearly daily basis. So allowing to have this microbial population present in the ecosystem, in that gut, where it can help exclude pathogens from coming into contact. Or with some of the prebiotics, they can occupy some of the binding sites on that basal surface, on the apical surface of the cells, preventing those pathogens from binding directly to the surface of the gut, helps keep these pathogens from getting a foothold. Furthermore, by producing the VFAs, the short-chain fatty acids, you provide enough energy to these epithelial cells in the gut to keep those tight junctions nice and tight, where there's not room for the pathogens to squeeze through to reach that basal side, to reach the lamina propria. Further, your dendritic cells can be educated, and if we've got pathogens, they're going to recognize the pathogens, and it will increase your cytokines in educating your B cells. But if your antigen-presenting cells, dendritic cells, don't encounter those pathogens because they're not there, you reduce a lot of that cytokine stimulation and that non-growth energy expenditure that your animals are facing from that constant low-level pathogen challenge. To me, this is one of the neatest studies that I've seen in a long time, and I really wish I did this study, but somebody else beat me to doing a really cool thing. And what they did is they had some Holstein cows that were milking, and they were pair matched between the two groups. So we have a control group at the top and a pair-fed probiotic pair-matched group. And the thing to notice, on day 0, they look fairly similar as far as their distribution. And what this is measuring is host gene expression. So looking at specific genes produced by that cow, in the cow, not looking at the microbes at all. And they have a pretty similar expression pattern on day 0. But after 60 days of being fed the probiotic, you can see between the control and the treated, there's a lot more blue in that blur of colors. And what happened was there were 11,000 different genes that were differentially regulated between the probiotic and the control. And of those 11,000 genes that were differentially regulated, 87 different bovine pathways were involved, including growth hormone, inflammatory response, all those issues. So it really looks very much like feeding a probiotic can actually directly impact gene expression by the cattle themselves. Now, again, since I know you guys are going to hear more about this, the anti-inflammatory plant options, but plants have long been used as anti-inflammatories and sources of antioxidants, from polyphenols, isothiocyanates, all those things. But they work together with the host animal not only to reduce the antioxidants in the animal, but they can manipulate and modify that microbial population, and they can do it in a way that is complementary to that probiotic or that eubiotic approach. Now, so looking at some essential acids and some botanicals derived from plants, just showing you that impact. So these organic acids and some limonene, terpenes, and oregano and some other naturally derived botanicals can shift that Firmicutes to Bacteroidetes ratio that I mentioned before in microbial populations in a dose-response fashion. And it can be used to impact the shedding of salmonella or affect the feed efficiency. And this was looking on this far right chart, was actually looking in pigs. But you can see the fact that we can affect shedding of pathogens and impact growth efficiency just by using some of these phytochemicals and or organic acids. So it's really exciting to see that we can manipulate this microbial population, trying to help get that animal more efficient. And these are some of our best tools that we have at this point. Now, one of the problems with looking at those microbiome studies that everybody is seeing right now is we're looking a little bit at something called survivorship bias. Now, the best example of that is during World War II, a lot of the bombers would go over from England and bomb Germany, and the planes would limp home, and they would do a battle damage assessment on each aircraft afterwards. And they were finding where the planes were hit in every mission. So they developed early heat maps of where planes were hit most often. So then they had a big meeting, and the decision was made, we should up armor these airplanes everywhere they're hit the most. So the plan was to up armor these points. Somebody puts his hand up and says, no, those are the places that we don't need to armor. Because remember, these are planes that are making it home. The ones that don't make it home, they're the ones hitting the vulnerable parts. And these planes that make it home, those parts are less vulnerable or less important because the planes make it home without them all the time. So when they applied that reasoning of eliminating survivorship bias, they found an area where planes were never hit, which meant that was the most vulnerable part of the plane. They armored it up, and it increased the aircraft's survival rate. So we've got to be careful when we're looking at the microbial populations. We don't fall victim to that survivorship bias or looking at something that seems logical. So we've got to look at our microbial populations to specifically improve that animal performance. So no matter what somebody's looking at telling you this is the best microbial population, we've got to remember the ultimate truth telling for us is from that cow and from your bottom line because of milk production. So overall, that microbiome that we're hearing way so much about is deeply embedded in animal performance and gut health. And having that established, stable population makes the animal more resilient and stable. But we can still improve it, or if we do something really bad, we can screw it all up. We can make those cows into a giant train wreck if we're not careful. So eventually, we hope that we can determine what's a good or a bad microbiome and be able to select that best eubiotic for use on the farm. And it may eventually be down to farm A probiotic or eubiotic, farm B eubiotic, where you're tailoring your eubiotic choice as a nutritionist based on the challenges faced on that farm, to the point where we can drive both sustainability and efficiency is a win-win. Additionally, we've got to make sure that we maintain both quality of milk production, keeping our composition the same or better, and quantity. So the goals of your producer always are going to matter. So with that, I appreciate y'all listening to me kind of wax philosophical, and be glad to answer any questions you guys have.
Thank you, Todd, for the great presentation. And yes, we do have some questions for you. So here's the first question. So in terms of anti-inflammatory effects, which class of phytochemicals stands out as most effective in improving gut barrier function in ruminants?
That is a great question. And I'm not sure that I've got one particular one in mind. I'm interested right now, and this is where it intersects with my research brain, is I'm looking a lot right now at things like some of the wintergreens, the eugenol type, some of those alcohols, and they look like they are working a lot on those inflammatory responses. And I think that's going to be most impactful in improving that gut barrier function. Now, that's an area of a lot of research. I know Lance Baumgart's looking at that and several other people as we're trying to figure out this whole, how do we make that gut barrier, how do we reduce gut permeability? So I don't know that there's a one that I would hang my hat on and say this is the best at this point. Ask us in a couple of years and we may have a better answer for that one, Rick. But right now, I kind of like those, like the wintergreens and the eugenols, but that's just where I am right now.
So we have one more question here, and it's related a lot to how the immune function plays a role with the dairy cow. So basically, in your vision, what is the impact of an immune modulation on cows' productivity parameters?
Ooh, that is a really good, loaded question, I've got to admit. Now, first of all, let me say I am not an immunologist. I teach a class in immunology, and every year when I teach it, I learn how little I actually know about immunology. But adding that inflammation piece to what we're seeing in the cattle, anything we can do to ratchet down that inflammation. Now, not all inflammation is bad, but the inflammation without a point or without a purpose for us, that's one that really starts to drain on the cows. It's going to pull down her efficiency. It's going to pull down or increase her non-growth energy expenditures. It's going to make everything harder for that cow. So if we can reduce that, especially the non-specific inflammation, kind of generally tamp that down, then I think that's going to, our data indicates, and I think it's true, that will increase some of the energy that is available for productivity, where we can add more weight to the milk or we can add more fat. And that's what some of the studies that have shown this immunomodulation, where we've reduced inflammation systemically, what it shows. So I think that's what we will see as we begin to get a bigger handle on this. And Frank Dunshea has done some really cool work looking at some of that immune modulation as well.
Thank you, Todd, for addressing these questions. I think these are all the questions that we have, and thank you again for the very nice presentation. So we will continue our program here, and before we take a break, we will have another presentation. Then we have a bio break, and then we come back with a couple more presentations. But our next talk will be from our next guest, which is Paul Franson from Volac. And today, Paul will be discussing with us everything about LPS binding in Ultrasorb next generation. Paul, welcome to the Dairy Summit. Thank you for joining us, and the floor is yours.
Thank you, Louise. I'm going to get my presentation on the screen. Hopefully it works. All right. Let me go here, share, and then get this one into presentation mode. Okay. Does this work, Louise? Hello? Right, lost connection there. Okay, I guess it's working. Anyway, so talk about LPS binding of Ultrasorb next generation. Let's say I'm working at Volac as a technical business manager and replacing Brian Miller today, or I must say tonight, because I live in the Netherlands, very close to the Friesland area, so where the Frisian cows come from. The more that we learn about mycotoxins, let's say, also the more we understand that mycotoxins are themselves cannot be really discussed without also looking at other stuff. So, and if you want to read a bit more about mycotoxins in general, I certainly advise get this book on your shelves. Also, nice paragraphs in there, published this year. Also, interesting pieces in there from Professor Antonio Galla from Milan University as well, who's a true ruminant and mycotoxin specialist. And the more we learn about mycotoxins, the more we also see that the effect of a mycotoxin depends a lot on other stress factors on the dairy cow, be it either heat stress or be it, for example, LPS, lipopolysaccharides. And so what I've also now seen is that if you can get more action against mycotoxin, but also against the LPS, we see a bigger efficacy. And the feedback we get now on our new Ultrasorb R3.0, the new version, is very positive. So it's confirming what we're trying to do. So we want to talk a bit about LPS binding, but also, let's say, why we look at LPS and lipopolysaccharides. I won't go into the detail here, but let's say they are parts of gram-negative, but also gram-positive bacteria. And when we look at some other species, just like Todd has done as well, is, for example, when we look at the piglets at weaning, if there's an LPS problem in the animal, we see a massive drop in feed intake, increase of diarrhea. We see definitely increases with the leaky gut, so increased tear, so transelectrical electric resistance, or transepithelial electric resistance, and inflammation responses. And actually within dairy cows, we see it to a lower degree. In case of piglets, you can have mortalities between 10 and 30% if it's really severe. Luckily with dairy cows, it doesn't go that bad. But one of the key things within dairy cows is the effect it has on inflammation responses. Todd already also briefly touched on tight junctions and proteins. And obviously, if you talk about things like mastitis and metritis, inflammation, also there, let's say these LPSs do play a role, but also in the case of acidosis, for example. And when we look at the gut barrier, and of course the gut is there to digest nutrients, but also protect the cell from harmful pathogens. So these tight junctions here have got an important role to play. And when we look at things, for example, like subacute rumen acidosis, we can actually see that the number of tight junction proteins measured in mRNA expression, like in these papers which are mentioned here on the bottom, we can see a significant increase, let's say 0.03, 0.016 of a number of tight junction proteins. So there is also a relation with acidosis as well, and we'll continue on that subject. A few other trials from 2015 and 2021. The first go here at the bottom, a paper from Wu. Different treatments, but main one here for us to use in this presentation is looking at feeding low concentrate or high concentrate diets, where we can see, as expected, a reduced rumen pH at the high concentrate level, but also that the rumen is producing a lot more LPS. But as long as the LPS stays inside the body of the animal, it doesn't really enter the bloodstream, for example, or it's up in the plasma, not a lot is going wrong. But if you see an increase, like we see here, like also an increase in the plasma LPS, that's when things get a bit worrying. In another trial from Maxu, 2015, also fed, let's say, low and high concentrate diets, you can actually see that over time we see a much reduced rumen pH at the high concentrate level compared to the low concentrate level. And here also you see an increase in rumen LPS as well as in plasma LPS. And you can also see clearly, also as with significant values, a drop in milk yield and a drop in fat production. Protein yield, not so much, but especially on fat production. Now, the question with LPS and all these things happening with a low rumen pH is actually what is causing this? Is it the feed intake? Is it the pH? Is it LPS? And in that sense, an interesting trial that was done by Opgenorth in 2024 has looked at pair feeding animals. And he did it in both early lactation, so 20 days in milk, and then mid lactation, under 31 days in milk. And when we looked at how much did LPS infusion, this was a 1 time a day infusion, as you can see here, we saw that the early lactation cows dropped their feed intake with 34% and the mid lactation with 11%. So the earlier in lactation, the more sensitive the animals seem to be to LPS. And when we look here at these graphs here, which is dry matter intake, you can actually see that, so the ones here, with the circles and the triangles, which are completely black, you can see that the pair fed group of the, let's say, negative control with the saline treatment had exactly the same dry matter intake, as well as for early lactation as well, same dry matter intake. And if we then start looking and say, what effect does this have on energy corrected milk? And there have a lot of other parameters as well, but just selected here energy corrected milk. You can see that the ones both in early lactation, also mid lactation, their energy corrected milk production compared to the negative control was massively lower. So here you can really say this is truly the LPS effect, not the low pH, because they didn't play with the pH. It's also not feed intake because it was pair fed. So LPS on itself really can have dramatic effects on animals. And if you do it in combination with mycotoxins, even more actually. Another interesting one from Reisinger in 2021, you also looked at, does LPS perhaps have an effect on the strength of claws of the cows? Back where I live in the Netherlands, if you talk people and ask them, let's say, does rumen acidosis have an effect on claw strength? 50% will say 100% yes, 50% will say 100% no. And what's interesting about this one, where they've just incubated the claws, let's say, with LPS, you can actually see a very significant reduction in claw strength or reduction in separation force if LPS is in the claws. So LPS, not a very good story. And if you take a little bit a step back and look at actually what's happening with LPS, an interesting review from Campanelli, did some trials as well, where we can see that with a reduction in rumen pH due to feeding more grains, so from 0 grain up to 45% grain, we can see a clear increase in endotoxins, which can be dangerous, especially if you also start having a leaky gut as well. And we know obviously that at these low pHs, let's say around the 4.7, 5, only the Streptococcus bovis and the Megasphaera alteni can actually survive. And the downside of these bacteria, which you have here, that can actually survive at the low rumen pH, is that they, apart from the acidosis and the hydrogen acidosis and the LPS and endotoxins, and what you already have, what you get on top, especially for milk fat production, is that you get more trans-10 rumen biohydrogenation. So that's the pathway which is then used. The trans-11 pathway is safe for the animals. Trans-10 means a reduction in your milk fat production. not the kind of things you want to have. It's the same with mice. Also there we see in combination with mycotoxins, endotoxins, or heat stress, the problem just gets bigger. It's not just a problem on its own. And so this is a problem. And what we try to do at Volek, apart from trying to bind mycotoxins or biotransfer, let's say the structure of the toxins, either with the yeast metabolites or live microorganisms, is also looking at, for example, electrostatic binding or van der Waals binding. Well, I think most of you will be familiar with aflatoxin. Aflatoxin is one of the most easy toxins to bind, in this case to clay minerals, quite well described. There are a number of authors, and actually it's mainly the charge, let's say, between the clay layers, which makes the aflatoxin, in this case, to be bound to the product. What we do as a Volek for larger feed mills, actually we can actually test it also for them, their own clays. What does it do? And then we can supply them with a core product to make up their own mycotoxin remediator. And we do a range of analysis. This is just an example from one customer measuring electrostatic binding at pH 3 and pH 7. You can see massive difference between the two. Just an example, but what we do as well is try to do a similar thing for endotoxins and LPS binding. So there's a standardized test for LPS binding. This is the toxin that's being used. And for doing the specific test is the horseshoe crab, which is being used, or the Limulus polyphemus. That's also why it's referred to subject as the Limulus test. And these animals literally have got blue blood, which doesn't run in my veins, but in the case of these crabs, it does. And the nice thing about the blood of these horseshoe crabs, it coagulates with LPS. So using this blood of this animal actually tells you something about what happens with the LPS, if there is there or if there isn't there. And that actually allowed us, as I say, to test a lot of different components and do a lot of, let's say, quite wide benchmarking of both raw materials in the market, but also competitor products in the market, and see if it can increase that LPS binding. So what you can see here, this is some benchmarking that we did. This is more or less where we started initially. And this is actually how we developed over time to be able actually to go to levels where we can close to 90% bind LPS endotoxins. And actually in that way have not only a solution for the mycotoxins, but only supported with an additional LPS binding as well. So that's my story for today, and I hope you've got some questions.
Well, so for while people here put their questions in the chat, I have a question for you. So whenever you are making recommendations about the best way to use those binders to avoid LPS, right? For example, how do you approach that? Do you use different approaches depending on the scenario? Like, for example, if you're working with a herd that you know that will have issues with...
Understand, I couldn't hear it clearly here.
Oh, I will start again. So whenever you are working with a herd that it has more potential for acidosis, like for example, heat stress, a very high grain diet.
Because 90% was, I think, bound to something that couldn't receive my ears.
So how do you do that? Like, what is the suggestion? To use more or less in those herds of binders compared to herds that don't have some of those issues, for example?
Well, in general, you would say, let's say, if there's really physiological and immunological stress on animals, be it, let's say, either heat stress or high production, for example, or rumen acidosis, try to do more things and not only focus on one thing. And especially on mycotoxins, you actually learn more and more. Is that, for example, you can have the same load of mycotoxins on a farm, and on one farm, nothing happens. Another farm, the cows have really got severe problems with it. And we see that, for example, in periods of heat stress, or for example, if there's also a rumen acidosis problem or an LPS problem. And so if there's a problem on the farm related with toxins, be it either endotoxins, try to have a more broad spectrum approach to tackle both of them. And the same thing with mycotoxins. There are very clear threshold levels for each individual mycotoxin. But if you look at what happens if you've got more than one mycotoxin contamination, that's where you see the big challenge. So the international community that deals with mycotoxins, if you would ask, do you have any specific formulas developed where you can see the combined risk of DAN, fumonisin, ceranone, T2, etc.? It doesn't exist yet, but we know, let's say, that having more mycotoxins just has a bigger effect than only having one mycotoxin. And the same actually goes with these endotoxins. It's just a bigger stress for the animal.
Absolutely. And if we continue with this topic about mycotoxins, and I know that you just mentioned a couple of the culprits here that cause a lot of problems, but which are the main mycotoxins that have the greatest practical impact on the health and performance of cattle that is fed silage-based diets?
Well, if I look at my area of the world, let's say, which is Netherlands, and I do technical support for our European team, so this is, let's say, complete Europe. At the moment, the biggest problem with dairy cows with cearalenone and deoxynivalenol. So DAN and ZEA, I'd say, are the most challenging ones at the moment in this part of the world for dairy cows. If you go a bit more south, let's say Italy, for example, where it's more hot, different climate, there we can also see an aflatoxin problem, so an aflatoxin M1, and obviously all the dairy producers or the dairy processors, so the milk factories, cheese factories, they test that for aflatoxin M1, but that's only, let's say, a challenge, let's say, more to the south of Europe, not so much in the colder climate.
And going back to the discussion, LPS or mycotoxin, what is the mechanism of LPS control compared with the mycotoxin control by binding? And then a couple other questions together with that. Is it an electrostatic reaction as well, or how is the control for the non-polar mycotoxins?
It also includes in it partly electrostatic binding, correct. If you compare it to, let's say, mycotoxin products, in mycotoxin products, especially with dairy cows, about 60% of it approximately is electrostatic binding from clays. And for the rest is, let's say, those components like yeast metabolites, for example, or yeast-based enzymes or synthetic enzymes, or live organisms, we can actually change the structure of the mycotoxin, as well as a smaller degree van der Waals binding as well.
Thank you, Paul. I don't see further questions here in the chat. So I'll take this opportunity to not only thank you again for sharing all those different mechanisms and obviously your insights about how complex LPS as well as mycotoxins are. And now we will have a 10-minute break so everyone can take the opportunity to stretch their legs a little bit and before continuing with the program. We also, people can take a bio break, grab a cup of coffee, water, anything you need, and we will be back soon. But before we go, I would like to thank one more time our sponsors. Of course, that the only reason why we are able to provide this great program to you today is because they are helping us by sponsoring this section. So thank you, AHV, ICC, Pro-Earth Animal Health, and Volek once again. And I will see you all in a couple of minutes.
Wisnetics, where knowledge comes alive, bringing ideas that make you thrive. From the experts to the field, we bridge the gap, connecting minds with every word and every chat. We're the pulse of progress, the voice of the wise, sharing insights, sparking minds, opening eyes. From research to practice, we break it down, turning complexity into knowledge renowned. Get smarter, get sharper with every listen. Ideas that grow, perspectives that glisten. From the lab to the farm, we're making waves. WiseNet, it's where the future is paved. We're more than just stories, we're learning in action, helping you stay ahead with every interaction. From the ground up, we build the flow. Wisenetics, the place where knowledge grows. From the lab to the farm, we're making waves. Wisenetics, where the future is paved. Wisenetics, 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 like the knowledge with notes. Wisenetics, we're the voice that breaks through. charge that I left unsaid. I can almost feel you walking in the distance, but I know that is not reality. If you are echoing around inside these parallel dimensions all alone, know I'll find you in my dreams. Just like the street lights lit this town, like a fire in a blaze, gotta burn it down. Can't be afraid to leave this out. We got this far, don't know how. I see danger in your eyes. They know we'll burn down the night. Coming just like the sunrise. You know that we gonna let it away. Tonight, we gonna let it away. Tonight, we gonna let it away. Just like the sunrise, we gonna let it away. Just like a spark that's breaking out. Can't make a stop, can't turn back now. We know that there's no room for doubt. No, we can't turn back now. I see danger in your eyes. They know we'll burn down the night. Coming just like the sunrise. You know that we gonna let it away. Tonight, we gonna let it away. Tonight, we gonna let it away. Just like the sunrise, we gonna let it away.
So hello again and welcome back, everyone. If you are just joining us, I'm Luis Ferreiro, and I'm your host this afternoon. Otherwise, I hope you had a nice break and took the chance to recharge your battery, because we will continue with a couple more presentations, and we'll be moving directly next to our next speaker. So please remember that after each presentation, we will have some time for Q&A. So if you have any questions, please feel free to post them in the chat, and we'll be going through those questions immediately after each of those presentations. So now I would like to welcome Dr. Andre Rigo from AHV to talk about using food supplements to improve animal health. Welcome, Dr. Rigo, and thank you so much for joining us today. The floor is yours.
Thank you so much, Luis. I really appreciated the invite from Wise Genetics to share a little bit about the use of supplements for animal health. It's a pleasure to be here. And honestly, it's a responsibility after the call from Dr. Todd Calloway and Paul Franzen to add more for this discussion and on the topic of today. So, guys, I will ask you to bear with me for this presentation. I truly believe that we can add a lot of you guys to think about it and see how can we use food supplements and plant-based phytochemicals to improve animal health. I think I would like to introduce or to start talking a little bit about the progression of the medicine, how that evolved in the last years. One of the concepts then presented by Dr. Peter Attia a few years ago was the evolution from how we are reacting to the problems to be more proactive on that one, and how much good habits, good nutrition, and the use in the adequate moments food supplements can make the humans live longer and with quality. So when we're looking for this, how can we use our food for today and how much benefits they can bring for our life, why not use that one in different ways? When we still talking about nutrition or the importance of that one, I would like to bring another interesting point then. Nutrition has evolved a lot when you're talking about athletes. There are a lot of the supplements that are very focused on the immune function or mediating inflammation in many ways, then can be used for athletes to recover, for the recovery phase. These people, they are working a very high performance way. They are using a lot of energy to play these sports and do that one, and they need to recover very quick. So a balanced nutrition and the use of the correct molecules for that one can bring a fast recovery and a better performance for these players. But we are not here to talk about players or athletes or humans, but we have one very important and a high performance athlete that we work with. This is our dairy cows. So in the end of the day, how can we use the supplements? How can we use the molecules available in plants to minimize the impact of the inflammation of these animals, recovery after some periods of stress, and maximize the performance of them? So when you talk about what can be done, one of the first points that we always bring it up is the immune response and immune systems. There are many studies and many things showing how much the Indian spices and other vegetables can have very important properties or good properties on anti-inflammatory situation and using as antioxidants. But it's important to say there are some synergy among them. Sometimes the molecule that we have in one specifically natural source, they need to have another one to enhance their impact. This is very well seen when we have curcumin, that's the active molecule from turmeric. Then honestly, it's not very bioavailable. However, when you add black pepper or pepperine, the molecule from black pepper, the availability or the function of these molecules increase a lot. So when we're talking about phytochemicals or supplements, it's very important to understand that we are not talking about sometimes one molecule, but the conjunction of different feed, different vegetables, and together they will provide a bioactive compound or provide the results that we are expecting. In one side, when you're talking about performance and food supplements, we are really working on to make the immune response active but not overwhelming. But on the other side, many things that we can do for the animals is just making their life easier, removing the defenses of the pathogenic bacteria, which can cause challenges for them on that one and use a lot of energy for this situation. There are many studies again showing how specifically spices and specifically vegetables can have a function of removing the defenses of the bacteria. This is specific on the quorum sensing inhibition. I will talk a little bit about quorum sensing in 1 minute, but basically is the mechanism that bacteria use to communicate among themselves. This quorum sensing leads to some phenotypes expression, and one of them is the biofilm production on that one. Biofilm is the protective layer of the bacteria, creating a very safe environment for them to multiply, exchange sometimes information, DNA, and making sure and providing to the bacteria a place where they can express and multiply very quick. And another point then these spices can work very well is controlling the other virulence factors like production of toxins or any other aspects that can overwhelming the host immune system. So when we have food or phytogenics, then we can one help on the immunomodulation and help the immune system along with removing the defenses or making the bacteria weak. These two things together make the performance of the animals way better and helping that one. The first thing then we need just to understand is what is the quorum sensing and how that works. Quorum sensing, at the end of the day, is the production of some specific peptides by a bacteria to communicate with the other bacteria. These peptides, when we have a specific concentration in the environment, the bacteria can sense there is a population over there. This population, the quorum, is started to express some specifically phenotypes, as I mentioned before. Interesting to see then these molecules produced by the bacteria, they can be working as very specific, or they are very good similarities among the molecules across other bacteria. What I mean is one molecule then can work in one bacteria to express the phenotype, can work for the other bacteria as well. So if you have different bacteria producing similar molecules to communicate among themselves, if you have a molecule able to compete for the same binding receptor in the other bacteria and you block that one, they don't communicate. And this molecule can have a very broad spectrum. And this is what AHV has investing a lot of efforts on. So in the end of the day, what we do is inhibition is the blocking of this quorum sensing and avoiding the bacteria to produce this to express these phenotypes. And we have tested these molecules, then we can find in different phytogenics, and we can supplement the animals orally in the lab to see if we can have the impact on the biofilm production of that one. Over here we have a test that we made in the lab in our headquarters in Walla, when we can see very clear then as soon as we achieve a concentration of that molecule in vitro in the lab, the bacteria stopped to produce biofilm. And this is worked for different kinds of bacteria like Klebsiella, Staphylococcus aureus, Streptococcus uberis, and E. coli. again, it's a broad spectrum molecule that can be used in very different ways. But lab is one thing. What happened in the real life? So how can we use these molecules to really improve the performance of the animals? And let's remember then, this is we are talking about a life cycle. The animal from the beginning as a calf up to the mature life, there is everything, every health event that can happen with this animal can impact in his longevity and in his production in the future. Over here, this is one of the studies that we make with Dr. Vinicius from Texas Tech University. The proposal was using a proactive protocol, working with the molecules that have these phytochemicals to improve performance of the calves. How we did that one? For the first 30 days, we give these molecules by the calves, mixed in milk. So every day they are receiving the bottle. And we follow the average daily gain for these animals for the first up to weaning, to be honest with you guys. And what we found then the animals then received the products, they performed better. They performed better because they were healthier animals, better production. If you take in consideration, one of the questions for Dr. Todd Calloway in the beginning is, what happens when an animal have an overwhelming immune response? They use too much energy. When they use too much energy, this energy is deviated from growth to maintenance. And that's what happened. When you can modulate the immune response, when we can remove the challenges from the calf, they will grow better. They will have a better performance. This is one of the things that we have seen over here. In this article, in this study specifically, we have a very interesting data. Then we decrease the scours incidence and pneumonia or BRD incidence significantly as well on these calves than they were in the treated group. Another very interesting point that I would like to bring over here is when we're talking about mature animals specifically. So what can be the effect of the application or providing these phytogenics molecules to mature cows, and specifically on their health? This is one study from Europe. Then we presented during the National Mastitis Council, Regional National Mastitis Council last August in Belgium, when we could see then when animals received the quorum quenching molecules, these animals, they can have a very reduction on the somatic cells count. And more than that, one very interesting thing, in this specific study, they cultured the animals prior giving the protocol. That means for the control group, the standard protocol containing antibiotics on that one, or in the treated group receiving the HV products, in this case extra. And it was very interesting then, animals, they were positive for Staph aureus before receiving the AHV treatment. After they calve, they became negative on the culture side. So showing then we can expose and we can limit the situation, or we can reduce these animals to continuing to be infected after that one. And in this specific article is one thing that works very well for organic dairies is our products, or the products that we have in these phytochemicals, they are organic approved. They are OMRI listed. So they can be used for organic cows as alternative for them. In organic dairies, we know we cannot use antibiotics. So what we have seen is how can we enhance the health of these animals using different ways. And here, this is another article, another presentation made during the DSA now in last July in 2025, where Dr. Pydal from Texas A&M could see then animals then have subclinical issues with other health or above 300,000 somatic cells count. When they received the molecules and the phytogenics, they had better health improvements, showing them they have higher milk yield. The animals then were culture positive for contagious bacteria, higher milk yield, higher drier and water intake, and less problems in the end of the day. So what does it mean? Why we are investing in these food supplements? Why we are investing too much on that one? We are moving for longevity. If you take a look on the cost of dowry replacements currently in the United States, it's really, really high. So maintaining a cow in the herd, for sure, a health cow, it's very important at this time. Along with, we know, mature animals, they produce more milk. And it's a very important economical impact for the dairies. I will just reflect about that one. If you are looking for longevity, in the beginning of the presentation, we're talking about recovery of these animals or recovery of athletes. What if you can minimize the stress for the cow as well during the dry off? What that happens? And this is where we are putting our focus at this time. HV is working in a different, different molecule to help these animals to reduce the impact of the dry off. And we are seeing very good results on that one. In the end of the day, if you guys remember what Dr. Todd Calloway said, there is every single time that we can work with the microbiome in situations that can express different phenotypes, or we can manipulate that one a little bit. What we're trying to do over here is reduce milk production in working with the Quorum sensing situation in the rumen microbiome. And what we have seen over here is we provided this specific product at the dry off of the animals, and we check the blood markers and the milk production after that one. Over here, I will keep myself focused on the dry off moment, because what we have seen is even we use phytochemicals to reduce milk production abruptly at the dry off, to reducing stress at the first 2 weeks and helping the rejuvenation of the epithelial cells. When we use that one, we have a very good impact on the metabolism of these animals, reducing the mobilization of the fats. We can see that one with reduction of the NIFAs prepartum, and increasing the liver function or helping the liver function, what we can see over here as well. So in the conclusion, we can see that the use of these new phytochemicals, the use of these molecules, they are providing a better, improving the energy metabolism for the animal and improving the liver health. And this will be impact after the post-calving as well. So this is what I would like to bring on that one. There are more studies coming about the usage of these food supplements and phytochemicals in animal health. And we are very excited to bring this one to you guys in the next time. Leaving here, please, this is my contacts, and I'm ready for the questions if you have any.
Thank you, Andrea, for the nice presentation. And yes, we do have some questions. I will start here while people take their time to put more questions into the chat. So our first question here is, in your opinion, what are the main benefits that quorum sensing brings to the performance and sustainability of dairy farms?
Yeah, absolutely, Luis. And I think I brought one of the points that we are seeing very important for the sustainability of the business and sustainability of the dairies is keeping the cows longer. When you keep the animals longer on a herd, the carbon footprint of these animals are reduced as well. These animals are more productive, and this impacts directly on the environmental and sustainability of that herd specifically. I truly believe then using the phytochemicals and improving profitability, productivity, and sustainability of these herds, they will make more families as well stay in the field and keep working with the dairies.
Absolutely. And we have a question that is related. So how can quorum quenching technology be practically applied to improve mastitis control in dairy herds?
It's an amazing question and very interesting as well. When we're talking about quorum quenching, one of the main mechanisms they control is the production of the biofilm. So when we talk about biofilm, we usually think about pipes in the parlor or other places when we can have the accumulation of the biofilm. But that happens inside the udder as well. And when we have this biofilm accumulation, this leads to less milk production and more immune response in some ways, because these are the cows and they are very chronic with a lot of cases of mastitis. So when we work on the quorum sensing inhibition and we remove the communication mechanism, this automatically leads to less production of the biofilm. And when we don't have biofilm, you don't have these chronic cows, then can get sick all the time. In the end of the day, you can control and more your mastitis incidence as well. Another point, when you have subclinical issues related with other health, high somatic cells count, this is a point when we can see that the chronic cows can have biofilm inside the udder. Removing this biofilm again, we can reduce this the immune response or the overwhelming and energy use for that one, along with more production of the milk.
Thank you, Andrea, for addressing those questions. I don't see any other questions in the chat, so we will continue with our program here. Thanks again for your nice presentation. I want to add that I really enjoy your connection between cows and high performance athletes, because that's exactly how I used to teach when I was teaching at the University of Florida. Because at the end of the day, those high producing cows, in reality, they have Michael Phelps type of metabolism, right? So I definitely think that there's a lot there that we have to pay close attention to. So I just wanted to mention that I really appreciated that. So thanks again, and we will continue our program with the next speaker. So last but not least, I would like to welcome James Davison from Pro-Earth Animal Health. James will be discussing with us about transition hutch calves into the feed pen. So thank you, James, for joining us today. We appreciate having you here, and the floor is yours.
Well, thank you. Thank you for having me. And with our first slide here, just to introduce what our product is, this is a feed additive that we've developed. We have an oral drench that affects pH and core temperature, and then we've developed this feed additive for daily support on animals that are either on pasture or on feed, whatever the situation they're in. We have a feed additive that can fit into the management scheme. So the cattle active RA is the actual feed product, and what it does is it's proven, we've proven it in the rumen to increase pH 0.7, 0.5 to 0.7, depending on what the pH of that rumen is, especially if we're down in the Sarah range, and we want to get back up into the low sixes or into the neutral range. We can do that every day, where we're not getting that heat of fermentation up so high that we're affecting the rumen lining. In doing that, we have increased the production of butyrate. We did that. We proved that in our VFA studies that we did on a typical finishing ration in a feedlot animal, and that had a really good effect when we started those calves in the first 30 days. As the prior speaker pointed out, those are really important times with how we can affect the health, how we can affect the performance by just basically maintaining rumen health and hydration in those calves. So when we go and we look at in the dairy situation, which mainly I work with a lot of feedlots that are receiving calves now, and with the price of the day olds and the half beef calves, that's mainly what I'm working with. So we develop protocols to get those animals back into production by maintaining their water intake and their feed intake by maintaining pH, so that we don't get the scours up front where that calf is starting to dehydrate and his rumen lining and his digestive tract is not working properly. So in the hutch, when they introduce the feed, that's our main goal right there. And it's very simple, and it doesn't take very much product, and it's very economical to do that. As we progress and we transition into out into the feed pens, we want to make that transition as short a period of time as possible, so that we don't get shrink right there and delay our shipping dates or delay our point of our goal in our weight goal there. So we're achieving our weight when we're wanting to ship those cattle, and we're not having to feed them longer and incur more expense. So if we could change slides right quick to basically, that's my bio. I'm a regional sales manager. I do go all over the country. I do have a BS in animal science. I've got about 40 years of experience starting cattle, preconditioning cattle, also in the cow-calf sector. And my goal is, in the shift of the production of beef calves, is to get more involved with the half beef, half dairy calves, as they're going to be a really good resource to supply the beef that and meet the demands of the American consumer. Because, as you know, our numbers are down due to drought and other influences on that. And with the southern border closed, a lot of beef producers in my area are looking towards the half beef, half dairy calf as a source of animals to keep their feedlots full and continue to feed cattle. So as a whole, what we've seen and what our goal is when we go in the dairy is to improve the colostrum that those calves receive, because those day-old calves, as we all know, they can be a challenge if they don't receive good colostrum. Maybe help that producer avoid some colostrum supplements or using colostrum alternatives, but to have that cow produce as nutritious and powerful of colostrum that it can to get into that calf. So once we get that start right there, and we've used our product in that cow, we can reduce the shedding, we can reduce scours in those calves. That's where our oral drench comes in. A lot of times, if it's tough calving conditions, say they have hot weather or the cattle are stressed, we can start that calf off with a drench dose and get his digestive tract ready to absorb that good colostrum. And then as we transition into the hutch and we start adding feed, then we can have our feed product in there and support that calf's digestive tract daily, so he performs at maximum. So those areas are what I'm looking at, because it seems when we get these calves, a lot of my producers aren't, quote, experienced at handling those calves, but they're having to learn how. So we're trying to work on the backside to with our dairy calf, hutch calf people that are providing these cattle and sourcing these cattle to have a healthier calf when it comes to the bigger feedlots and puts in the growth situation all the way to finishing. So we feel like that maintaining the pH of the rumen has a lot to do with the overall health of the animal. We don't get a cortisol spike. We don't get a hyperimmune response. We maintain our intakes and our water consumption, and all of those contribute to the health of the animal. So if we can switch slides right quick, we'll look at just what we showed that we did with the VFA values by treating the feed, or adding this feed additive, if you will, to the feed on a daily basis. And we did this with a traditional, about a 68% corn ration in cannulated cattle. And as you can see, we have a control. We have a Monensin group. We have the Cattle Active RA group, and then the Monensin and the Cattle Active group. And so just going by that data, we did sacrifice a little bit of acetate and a little bit of our propionate compared to our control, but our butyrate levels were 12 to 13% higher. And when we followed these cattle all the way out to harvest, that's where we had our impact on not only on days of feed, but conversion was excellent. And we fed the cattle less period of time and had a higher quality in those cattle. So we've done that in some dairy cows, working with veterinarians, looking at the effect in the dairies on calf scours and on the cows themselves. We did have an impact by maintaining pH in those cows in the first milk of up to 9 pounds in some of those cows. So we know we can help health, we can help production throughout that model, whether it's in those calves in the hutch, out in the feed pen, or as they go on into the finishing stage. And also we've had good luck helping the cows through pre-parturition and post-parturition, and reducing the incidence of scours, which is where we got our start in the beef industry. We go in and get protocols designed for producers that have had year after year after scour problems in their herds. And by maintaining pH, however we did it with drench or with a lick tub, or if they're on a TMR, we've added our feed additive to that. And the cattle's immune system have started to function really well, and production's up. And we've really reduced the incidence of shedding from the cow to the calf and causing scours. So let's go one more slide here, and we can verify the effects that we've had in the first 30 days. And these were heavier cattle, obviously, but this is showing the difference in those first 30 days in those 4 different diets, and how the cattle responded to that with their average daily gains and their intake. And if you notice, the Cattle Active group excelled there, and the Monensin and Cattle Active group was second. And I think what's important, and it's been important to my producers over the years, is yes, we're consuming a little less, but we're producing more with that. So our conversion is there. And as we track the economic effect of conversion, we're seeing that really improve carcass value out in the end. And with the consistency of the dairy beef calf cross and the effect that, the success that producers are having using them for a cattle source, we're really seeing a big impact in total carcass value on the end on those cattle. So from basically taking a proactive approach, which I think all of us are seeing today is the way to go. When we start cleaning the cow herd up and we get those calves started off correctly and their digestive system's working correctly, then we fuel the immune system. We see less scars, we see less respiratory problems, we reduce our shrink, and therefore in the end product we're improving the value of those cattle to the producer. I think sustainability is a big thing to talk about here. We're using a little less feed by improving conversion, and we're producing more with less cattle, which is gonna help in times like these with the encroachment of suburban on all the ranch lands, and we're losing ranch lands to producing cattle. We've got to look to our dairy partners and look to them for a source of cattle. So we're going to have to get better at managing those cattle, and we're doing a pretty good job these days. But I think some help here and there with a simple product like ours is showing a good effect and showing its economic benefit to these producers. So we can change one more slide, just a little bit more about our product. And we are IMI Global certified. We're available to go in any all natural programs. We do produce it in an ionophore-free facility. We have different forms to really make it easy to fit into mixing situations, all the way from micro, that'll go through the micro machine. We have a granular, and then we also have a pellet, both of those being used in batch mixing systems. So it's a very flexible product. It's very simple, manufactured very safely, and it's proven to be a very trustworthy product for producers. So I'll end it right there and take any questions that we have.
So thank you, James, for your presentation. While people put their questions in the chat, I have a quick question for you. Do you see any differences when using the pellet or the granular product?
Well, I think the main reason it seems kind of simple, but from an ease of mixing, we got started in a lot of farmer feeder situations, and for them, some of them were very rudimentary, and so they're just throwing the pellet up over the side of the truck. If we used the granular there, if they were in the wind, it blew it away. So the pellets were easier to get over the top. But also in these smaller calves, that pellet has a scent to it that we can top dress and pull groups of calves to the bunk because of that scent. And I think that was an important thing in developing the pellet. The others also have that aroma to them, but the pellet is more, it's works better in a top dress situation.
And from your perspective, what is the most critical window, to start addressing those potential metabolic disorders early enough that we do not compromise our entire production system?
Well, I think just in my experience, where we've seen the biggest impact, I like to go in to the last trimester with any kind of nutritional support, because I think that's where your cow needs to start really absorbing all the nutrition that we're giving her, so that we're producing a healthy calf when she does calf. So I think 90 days before allows us to really assist that cow to heal any problems she's having in her digestive tract, get her micropopulation consistent and adjusted to that ration. And then I know one issue that we've dealt with in on the farm itself is right after parturition, we can have an appetite problem in those cows, and that's where our drench comes into play, and we can correct that stress from parturition real quick. And then that's when our we'll get those cattle up there to eat and eat enough of the feed additive to do some good. So from that perspective, I like to start those cows off early, and then we don't have near the incidences of problems after they calf and into that first 21, 30 days of lactation.
So prevention is definitely the best approach, and I do agree with you, and I think there's a lot there that we have to make sure those animals are not exposed to in order to perform well. So thanks again, James. These are all the questions that we had. We appreciate your presentation and participation here in the Dairy Summit. So to close our event, I would like to thank everyone for joining us today and stay with us until now. It has been a pleasure to have you this afternoon. And obviously, I would also like to thank our speakers who took time out of their day to share their expertise with us and all this information. Also, thank to our sponsors. Without those sponsors, it wouldn't be possible for us to have the Dairy Summit today. So thank you, AHV, ICC, Pro Earth Animal Health, and VOLAC. We really appreciate your support. So thank you again, everyone. I hope you have a fantastic day and hope to see you soon.